Good morning, students. In the last lecture, we have seen some of the examples related to the distance and the displacement. And with the help of that sums, we try to understand the distance and displacement, right? And we have seen that the object is moving on a straight line, and during that time, how you can calculate the distance and how you can calculate the displacement. On what will be the changes in the distance and displacement according to the path. Today, we will see some of the examples which are not related to the straight path. They are moving on a square path or something like a circular path, right? At here you can see one square path, right? On a rectangular path or something like that. At when, in which example, you can see that one object is moving on a straight path, but after some distance, it just try to turn on another straight path. It is also one type of straight path, but after some distance, it just tries to change its direction exactly to 90 degrees, right? So you can say that when object is moving on a rectangular path or a square path, how can you calculate the distance and the displacement? It is in the same manner, but you will see some of the changes in the displacement. How can you find the displacement according to this path? Distance is the same, right? Okay, now, and here I am just reading a question of an example, okay? There is one object is moving on a path which is shown in figure. At here, there is a figure on which this object is moving. But from which point to which point? At here, if object is moving from point A to B, means it is moving from A to B, then B to C, then when it reaches to the B, after that it tries to moving on towards the C on this path, right? Then B to at here, then C to D, it reaches to the C now, right? It reached at here. So after that, just moving from C to D and reaches to the point A, then it just comes to point A. Then you have to calculate the distance and the displacement. How can you calculate the distance and the displacement? Okay, now first of all, we are going to calculate a distance. Do you know what is the distance? It's the total path. So here it is a total path. What is the path of that object? It's from A to B, so A, B. B to C, so B, C. C to D, so C, D. And D to, so the D. Now the value of AB, it's a 4. Value of BC, it's a 3. Value of CD, what is the value of CD? It is exactly the opposite side of AB, right? And this part is a rectangle. So you can say that the opposite sides are equal. So the CD is also of 4 km, as AB is 4 km. So the CD is 4. Like that, the DA. DA is the opposite side of BC. So if the BC is 3 km, then the AD is also 3 km. So here it is. Then what is the distance? 4 plus 3, 7. 4 plus 3, 7. 7 plus 7, 14. So like that, you can calculate the distance. Now, displacement. In this example, you can't use that equation which you have used in a straight line that we are using as the AB plus BC plus CD plus D, because in that examples we have seen the object is written on the same path but in opposite direction. At here, object is not moving in opposite direction. There is another direction which is exactly perpendicular to the first one. Right? At here, if it is moving from A to B, then the B to C, then BC is perpendicular to AB. After that, C to D, then the CD is perpendicular to BC. Then the DA, then it is perpendicular to CD. At here, you have to use some of the cos theta and sin theta like equation, which you will see in a 11th standard, right? When you study some sine, cos in a maths, during that time you will see in a 11th standard. Okay. Now you have to use only one equation, which is final position to the initial position, a minimum distance initial to the final position. So according to it, minimum distance from initial to final position. Now, what is the initial one? Initial is a A. What is final one? Final one is A. So the distance, so the displacement is 0 kilometer. Just remember that when object returns back on the same path, you can use that one equation which are used instead of it, right? In our first 4 sums, we have seen another one equation also at here for calculating a displacement. But at here we can't use it because there is no returning path. The object moving on a different direction, but which is not opposite to the first one, right? It is perpendicular to them, right? And for that you have to use the sine and cos like equation, which we'll see in 11th standard when you study a sine cos type tangent equation in a maths, right? At here you have to use just this equation and you can easily calculate the displacement at here. Okay, understand? So here it is our first example, which is a square part, right? Which has a square part. The distance is total part, which is as same as the previously we have seen. And at here the displacement, which is the minimum distance from initial to final. Initial is A, final is A. So you get 0 kilometer, right? Just see carefully. Now, we will see another example. Question number 6. Now, one object is moving on a path which is shown in figure. If object is moving from A to B, then B to C, then C to D. Calculate. Calculate distance and displacement. Now, object is just moving from A to B, B to C, and C to D only. It does not reaches to D. Now you have to calculate the distance and the displacement. Now, distance. Total part it's from A to B, B to C, and C to D. What is AB? 4. B to C, 3, and C to D, 4. So it's a 11 kilo. Distance is this, right? Now the displacement. It's a minimum distance from initial to final position. It is a minimum distance from initial to the final position. What is the initial position? It's A. And what is the final? It's A. So you have to find AB. What is the value of AB? According to figure. Here it is A, B, C, and D. What you have to find? AD. It doesn't mean you have to find like that. Total you have to just take this part, A to B, which is exactly like this, right? So according to it, you can say that AD is equal to BC. So what is the value of BC? It's a 3 kilo. So the displacement is 3 kilo. Displacement is 3 kilo. Understand? At here, you have to find the displacement, which is at here, a minimum distance. If you take this one, then it is a maximum one. You have to take a minimum. Minimum means if you take a straight path, then you can say that it is a minimum distance. So minimum is AB, which is exactly opposite to the BC. So you get the value of AB, which is 3 kilometers. So like that, you can calculate a displacement at here. The distance is total path, which is 11. But the displacement is minimum distance from initial to final, right? Which is 3 kilometers. According to opposite sides of a rectangles are same. And just because of that, you can say that the displacement is 3 kilometers. Just see it carefully. Now, another one. Question number 7. Just read it carefully. One object is moving on a path which is shown in figure. There is it. If object is moving from A to B, then B to C, calculate distance and the displacement. At here, object is just moving from A to B and B to C. Here it is the path which is shown in figure, and the object is moving on this path. Now you have to find the distance and displacement. How? First of all, distance, which is very easy for us. It's a total path. What is total path? AB plus BC. AB is 4, BC is 3. To get the distance, which is 7 kilometers. Now, the displacement. What is displacement? It's a minimum distance from initial to final position. Minimum distance from initial to final position. What is initial position? It's A. Initial position is A, and the final one is C. How can you calculate this one? For that, you have to remember this way. Right? A straight path from A to C. So you have to find out this. You have to find out this. Here are 4, here 3. How can you calculate? According to Pythagoras theorem. According to Pythagoras theorem. Right? You have to find out the AC. For that, for finding AC. AC square. AC square is equal to AB square plus BC square. According to Pythagoras theorem, AC square is equal to AB square plus BC square. Right? You have to take the square of another two sides. The summation of square of another two sides. So the AB square plus BC square. What is AB? It's a 4 square. What is BC? It's a 3 square. Here it is AC square. 16 plus 9 is equal to 20. AC square is 25. Then the AC is 5 kilometer. So the displacement is 5 kilometer. At here, just look at here. Displacement minimum distance. So A and C at here. Right? For finding them, you have to take the Pythagoras theorem. So the AC square is equal to AB square plus BC square. If you want to find out this one, this side, then you have to use a summation of another two sides square, right? So here it is the AB square plus BC square. AB means it's a 4. 4 square plus 3 square, which is 16 plus 9, which is 25. So you get AC as a 5 kilometer. So 5 square is 25. So AC is 5. So you get the displacement, which is 5 kilometers. So like that, you can calculate the displacement. So at here you have seen how the different types of how you can calculate a displacement in a different part, in a different way. You have to use a different types of formula for them. Right? At here you have used one of the theorem of maths, which is the Pythagoras theorem. Trigonometry, right? So at here it's a 5 kilometer. Understand? Just see it carefully. So now, like that, you have seen some of the examples which is related to the different types of part in which object is just turned at some perpendicular distance, right? At some perpendicular direction, right? Now, we will see about this spherical part, okay? If we take at here, example is if one object is moving on a circular path of radius 5 kilometers. We will take it 5 not a 5 as a 7 sound. It will be easy for us, okay? Just for understanding. So, if an object is moving on a circular path of radius 7 kilometers, if it completes one rotation, calculate distance and displacement. Now, if one object is moving on a circular path of a radius 7 km, if it completes a one rotation, then calculate a distance and displacement. Now, okay. Now you have to find out the distance and displacement. Figure is in our answer now, right? You have to draw one circle. So now, object is moving on this path. Okay, the radius is 7 km. The radius is 7 km. At here, object completes a one rotation. So if we take it here A, then object starts its journey from A and reaches to A. So now you have to calculate a distance and the displacement. What will be the distance? Distance. what you can say about the distance? Is it 7 kilometer or 14 kilometer or 27 kilometer? If object is moving on this circular path, do you know what is said according to the trigonometry for this? A circular path, a circular path. Not inside of it, it is not the area, it is not the volume. Just take it this, a sides of this circle. What is called? It's a circumference, right? So you have to take the circumference. So you have to take the circumference of circle. Do you know what is the equation of circumference? It's a 2 pi. It's a 2 pi. So here it is 2. Now take the value of pi. 22 by 7. If this value is given to you, then you have to take it here. If not, then you have to take a 3.40, right? So here I am taking 22 by 7. Now R is 7. So the 7 are cancel. What is the answer? It's a 44 kilometer. It is main part for this type of example, a distance, which is circumference of circle. Displacement is easy. Minimum distance from initial to final position. Right? Initial is A. Completes a one rotation, it reaches to the main point. So it gives you a 0. Right? So here it is distance and here it is displacement. Just do it. Now, if I change this question like that, it's 8-1, right? That is the 8-1. Okay? If we change it like, we take it as another example as if it completes a 2 rotation, then what will happen? At here you have to take a distance is equal to 2 into circumference. So the equation will becomes like that. 2 into 88 kilometers. And the displacement is same. So whenever this type of equations are there, and if it completes some number of rotation, then you have to take that number as a multiplication with the circumference of a circle. Then you get the distance with it. Okay? You have to take that one, which should be multiplied with the circumference of a circle, and you get the answer. Okay? You have to take the value of pi, which is given to you in your bracket. If there is no value given in at here, then you have to take a 3.14 as a value of pi. For a pi, you have to take a 3.14. Otherwise, you have to take the value which is given to you in your bracket. Okay? In a question. Now the 10. Okay. Action. If, question number 10, okay? If one object is moving on a circular path of a radius 7 km, if it completes 1.5 rotation, calculate distance and displacement. 1.5. What you have to take at here as a distance? What is the meaning of 1.5? Full 1 and the half, 1.5. If you 2.5, 2.5. 3.5, 3.5. So at here you have to take a 1.5 into circumference of a circle. So at here 1.5. If we take it here as a radius, make it easy, right? So 5 kilometer. And we are not taking the value of pi. So you have to use the value of pi as a 3.14. So at here 1.5 into 2 pi r. 1.5 into 2, 3.14, r is a 5. If you take it, does not take 10, also it's good. 10, 2, 314 by 100 into 5 to 10. It's alright. 314 into 15. What is the answer? So the answer is 47.10 kilometers. Divide by 100 just because of that. Okay, I think you are good in maths. Okay, so again the answer is, the total multiplication is 314 into 15 is a 4710. But as there is 100 in a division, so you have to cut the 2 points. So it's a 47.10 kilometer. Now the displacement is minimum distance from initial to final position. Now, object completes of one rotation, then a half. If it starts its journey from here, like that. If it completes a full rotation, then a half. Then it reaches at here a point B. Now you have to calculate a minimum distance from initial to final. So you are just saying that a half of circumference, then it's wrong, because you have to take here minimum distance, a straight path, right? Minimum distance means you have to take a straight path at here, which is A and B, right? Which is AB. Do you know what is AB? Twice the radius, diameter, right? So here, diameter. Which is 2 into r. So 2 into 5, which gives you 10 kilo. So the displacement is 10 kilometer, while the distance is 47.10 kilometer. So like that, you can calculate distance and the displacement. You have to do this type of question by your own self. Make a question and then solve it. It is very easy for you and understand it, right? So just see carefully. So here it is the examples related to the distance and displacement. In the next video, we will see the another physical quantity. Now the distance and displacements are over at here, and we will see some of the questions which are given to you in your book, right? You have to solve this type of questions in your book according to your book, right? There is some questions given to you. After some of the portion, there is some questions given to you in a blue lines, right? So you have to solve this type of question also. There is one example also given to you, which is about a farm. Like there is one person or a farmer is moving on the sides of a farm, right? Like that. This example also you have to do by yourself. If you can't, then I will explain it in a next video. Then you can do that. Okay? But just try it by yourself also. Thanks.